Okay, so your study guide looks just like mine. I'm going to zoom in so you all can see what I'm doing. Can you read this, Madison? Can you read what's up here on the board? Is it big enough? Okay, can you read it, Selena? Aiden, you see this?
Yes.
Okay, awesome. So we're just going to go through and answer them, and hopefully, if you got it right, awesome. If not, hopefully you will be able to write it down. So each one of these are I can statements, meaning that they should be true for you by the time you get through. So you should be able to write this fraction as a decimal. How do we do that? What did we have to do to be able to change a fraction into a decimal? What operation does this fraction bar mean to do? Madison? Divide. So that tells me that in order to change this into a decimal, I have to divide. Which one's going to go on the inside when I divide? The 2. The top number always goes on the inside. The bottom number will go on the outside. 3 does not go into 2, so what can I do, Kaylin? Before I add a 0, what do I need? Because if I add a 0, it'll become 30. So what can I put in? What can I put in front of the 0? It's a little bitty dot. A decimal. So I'm going to add a decimal and then a 0. Now, does 3 go into 20? Yeah, how many times? 6 times. 3 times 6 is 18. Subtract. Uh-oh, I got some left over. So what do I need to do? Easton? Add another 0. Bring it down. Does 3 go into 20? How many times? 6. Do y'all notice anything that's happening?
Yes.
It's a pattern. It's repeating itself. So you have what's called terminating decimals where they stop, and then you have repeating decimals where they just keep repeating the same numbers over and over. So this is called a repeating decimal, meaning if I was to keep going, I would just keep getting 6, 6, 6, 6, 6, like all the way down. So I don't want to keep doing that for the entire class. So my decimal is going to go straight up, and I'm going to write down what I have. But if I leave it like this, it looks like it ends, like it's done. So what can I do to make it show that it's going to be repeating, Kayla? Draw a line over what number? The 6. You want to draw a line over the number that repeats itself. Okay? So Dex, I have to do the same thing for number 2 that I did for number 1. Means I have to divide. What number is going to go on the inside?
7 over 9.
The 7's going to go on the inside. The 9's going to go on the outside. The other classes I took this test, when they messed up, it was because they put it backwards. They put the 9 on the inside. So if you're unsure if this is set up right, let us know and we can help. So 9 doesn't go into 7. What can I do though to make me be able to divide? What can I do, Esmeralda? Add a decimal and then a 0. Does 9 go into 70? Madison, how many times?
9.
9 doesn't go into 70 9 times. Goes in there 7 times. 9 times 7 is 63. When I subtract, remember you have to regroup. So this becomes a 10 and that becomes a 6. 10 minus 3 is 7. 6 minus 6 is 0. What do I do next? Contessa, what could I do? I have to add a 0 first and bring it down. Does 9 go into 70, Willow? How many times? Anyone notice anything? What's happening? It's another repeating decimal. So I'm going to bring the decimal straight up. And how do I write it over here in the answer blank? What would I do, Madison? That's not it. What else could I do, Esmeralda? I gotta add a line on top. If there's a pattern, if it's repeating itself, you have to add that line. If you don't add the line, then it doesn't tell me that it's repeating. So any questions on number 1 or 2? Aiden, you getting this wrote down? If I'm writing this down, you need to write this down. Okay. So the second one, these are just adding and subtracting integers. So yesterday you were allowed to use this sheet, and I'm probably going to let you use it on the test as well. And it has those rules for adding and subtracting. So if I'm adding, I have to know, are they the same sign or different signs? So this is an addition problem. Are they the same sign or different signs, Contessa? They're the same. So if they're the same, am I going to add or subtract, Junior? If they're the same, I'm just going to add. And 5 plus 2 equals what? 7. Is it going to be a positive answer or a negative answer, Selena?
Negative.
It's going to be negative because both of these numbers are negative as well. Easy enough. Whole numbers, we can add them. This next one, though, it's a subtraction problem. So when you see a subtraction problem, what do you have to do to subtraction, Easton? Keep, change, change. How would I rewrite the problem after keep, change, change? What would it become?
The subtraction sign plus and the 12 is negative.
What happens to the negative 3?
Six.
Negative 3 stays the same. So now I have negative 3 plus negative 12. I go back to my questions. Are they the same sign or different signs, Travis? Are they the same sign or different signs? They're the same. They're both negative. So if they're the same sign, do I add or subtract, Willow? If same sign, you add. And 3 plus 12 is what, Landon? 15. Is my answer positive or negative, Dex?
It is
They're both negative, so my answer would be what?
positive.
Remember, if they're the same sign, you keep the sign the same. So if you're adding two negatives, my answer is going to be negative. Okay? So any questions about being able to add and subtract whole numbers? Now we got to multiply and divide whole numbers. So these rules are a little different. They're on this same paper, and they're also on that purple poster behind Junior. So when you multiply and divide, you multiply and divide like normal. You don't have to change anything. If they're the same sign, it's going to be a positive answer no matter what sign it is. If they're different signs, it's going to be a negative answer no matter what sign it is. So I'm just going to multiply and divide like normal. So what is 4 times 7? Remember, you can look up there at the 4 and count 7 times if you need to. So what would 4 times 7 be, Junior? 28. Is my answer going to be positive or negative, Contessa? It's going to be negative because they're different signs. Number 6. What does this fraction bar mean? Does it mean are we multiplying or dividing here? Keelan, what are we doing? We're going to divide. When you see parentheses, like when you see them side by side, it means you're going to multiply. But when you see a slash, it means you're going to divide. So 63 divided by 7. You can use that if the big numbers, go to the 7 and count until you get to the 63. And how many times would 7 go into 63? 9 times. Is my answer going to be positive or negative, Shelby? If I have a negative divided by a negative, it would be positive because same signs are positive in multiplication and division. Okay, so I don't know if I've asked this class to do it or not, but a lot of times I like to know kind of where you're at individually. And I ask you all to give me either a thumbs up, meaning you're good, a thumbs in the middle, meaning I'm okay, but I could use some practice, or a thumbs down, meaning you're completely lost. And it's not anyone else's business in the back row what people in the front row put. So I don't want you to hold your hand up like this. I want you to put it right in front of your kind of chest area. And that way I can see kind of how you feel and whatnot. So how do we feel about whole numbers? Adding, subtracting, multiplying, and dividing whole numbers. Okay. So those of you that, well, actually not even that. So are there any questions or things that you all want to practice? Because we have room over here. We can do some extra practice off to the side. Madison? So dividing numbers? Okay, so let's go with, you want to practice a 9? Dividing 9s? So let's go with 54, negative 54 divided by 9. So if you're doing this without a calculator, you can simply look at the big 9 up there on the side, and you can count until you get to 54. Another trick, I just saw Madison do it. So the 9s are kind of special. So if you have 54 divided by 9, you can, so if 9 divided by 1 is just going to be 9. That's how many fingers you have. 9 divided by 2, 9 times 2 is 18. 3 is 27, because that's your fingers. 4 is 36. 5 is 45, because you're looking on the two sides. 6 would be 50 on one side and 4 on the other. So that's another way to do the 9s if you need to. But so if I need 54, how many times would you count until you got to 9? Or you would count 6 times. But is my answer going to be positive or negative, Cariana?
Negative?
It would be negative because they're different signs. Okay? So just remember, if they're side by side like this, it's going to be positive. But if there's a slash in between them, it's going to be, if they're side by side, it's going to be multiplication. And if there's a slash, it's going to be division. Yes?
How come in multiplication and division, if they're the same, they're positive, if they're different, they're negative, but in adding and subtracting?
That I know a lot of math answers, but that one I don't know because I was just taught the rules like you are. They came up with the rules a whole long time ago. And so my best guess is, so in adding and subtracting, so when you subtract numbers, if you're at the number 5 and you add a positive number, you go onto the positive side.
Mm-hmm.
But if you add a negative number, you have to go backwards. And if it's larger than the 5, then it's going to be on the negative side. Whereas if you're multiplying numbers, negative 5 times negative 2 is going to be positive 10 because you have 5 groups of negative 2. Whereas the negative times the positive, they kind of cancel out. That's the best I can come up with. That might be a good question, though, to Google and see who came up with those rules. Yeah, well, I don't know if they're still living because math is a really, really old subject. So, I know. So, let's look at decimals and fractions. So, this was the other part that we did. So, we added and subtracted decimals and fractions. You use the same rules. If you're adding and subtracting, same sign you add, different sign you subtract. And that's what we're doing here. So 4.7 and negative 2.36. Do I have to rewrite this problem, Kimberly? No, it's already addition. So are my signs the same or different, Easton? They're different, so am I going to add or subtract, Junior? I'm going to subtract. Now, when you subtract decimals, the main thing to remember is that your decimals have to line up. So even if one number sticks out, you still have to have your decimals lined up. So I'm going to put a 0 in the blank space just to hold it open. And then I have to regroup. So my 0 becomes a 10, my 7 becomes a 6. So 10 minus 6 is 4, 6 minus 3 is 3, 4 minus 2 is 2. My decimal goes straight down. And is my answer going to be positive or negative? Willow, would my answer be positive or negative? Which one's bigger, the 4 or the 2? The 4 is larger, so it's going to stay positive. Now for my decimal, this is a subtraction problem. Travis, do I have to subtract? Do I have to rewrite subtraction problems? I do have to rewrite them. What are those steps that I do to rewrite them? Starts with a keep, and then what? You can do it that way. You can do keep, switch, it's the same thing. So how would I rewrite it though? If I keep the negative 3.75, what would happen next? What would happen to this subtraction sign? And what would happen to this, the negative number? If you switch the negative, what does it become? Becomes positive. And now I have to go back to my rules. Are they the same sign or different sign, Selena? When I rewrote them, they became different. Just like over here, if they're different, I'm going to subtract. So I'm going to line up my decimals. So 5, remember, another thing to remember, biggest number always goes on top in subtraction. Doesn't matter if it comes first or second, it has to go on top. So 5.62 goes on top, 3.75 goes on the bottom. I cannot do 2 minus 5. This becomes a 12. 12 minus 5 is what? 12 minus 5. Madison? 7. When I borrowed from the 12 or made this a 12, this became a 5. And again, I can't do 5 minus 7. So this becomes a 4 and that becomes a 15. 15 minus 7 is 8. 4 minus 3 is 1. Bring down my decimal. So my answer is 1.87. But is it going to be positive or negative? Keelan? Negative. It's going to, well, which one's bigger, the negative 3 or the positive 5? So it's going to, my answer is going to be positive. So remember, if they're different signs, the bigger one keeps the sign. Now my fractions. Same rules. If these are different signs, so I'm going to subtract, but my bottom number is different. So how can I turn my 3 into a 6, Landon? Multiply by 2. So this becomes 2 times 1 and 2 times 3, and then 3, 6. So you all said these are different. I'm going to subtract these because they're different signs. What's 3 minus 2? If you have 3 and you take 2 away, what do you end up with, Contessa? 1. And my bottom number stays the same. If this was a -3 and that was a positive, what number is my answer going to be, negative or positive? My answer is going to be negative because it was larger. So this is a -1/6. So fractions aren't too bad. It's just that you have to make the bottom number the same before you can do anything with them. Over here, I have a subtraction problem. How do I rewrite subtraction? What are the 3 steps that you use to rewrite subtraction? Do you remember, Easton? Keep, switch, flip, however you want to call it. Keep, change, change, keep, switch, flip, whatever it is. So how would I rewrite this then? What would it become when I rewrote it? Willow, what would it become? Good. Are these the same signs or different, Esmeralda? I have a -7/12 and a -1/4. So they're the same. Do I add or subtract same signs, Contessa? I add them. Can I add it how it is? Can I add 7/12 and 1/4? Shelby, what do I need to do? I need to make the 4 into a 12 by multiplying by 3. So 1 times 3 is 3. 4 times 3 is 12. So now I have 7/12 and 3/12. Now can I add them? Yeah, they're the same. So what's 7 plus 3? 10. Keep the 12. Is my answer going to be negative or positive? When I rewrote it, I had a negative plus a negative. So is my answer negative or positive? It's going to be negative. Okay, so do the little thumbs up, thumbs down thing. How do we feel about adding and subtracting decimals and fractions? Yeah, fractions aren't the best. Like, fractions are a little tough, but we'll get through it, I promise. So tomorrow, there won't be too many fraction questions on your test, just a few. Let's go on to multiplying and dividing fractions and decimals. So to save time, I'm only going to do 1 fraction and 1 decimal, just because we don't have that much time left. So when you're dividing fractions, what are the steps that you do when you divide fractions? Same thing you do when you have subtraction. What do you do when you divide fractions? Or keep, switch, flip. So, good grief. I will eventually find a pen that works. There you go. So I'm going to keep the 3, 6. What do I change the division sign to? Times. And I'm going to flip this. Now, I can't flip it because I have a whole number. How can I get rid of the whole number, Madison? The C method. And Contessa, what does the C method mean? What do you do? I put it on the spot. I start at the 7. I'm going to multiply the 7 times 1. And then what do I do with the 4? I add. Exactly. So 7 times 1 is 7. And then that plus 4 is 11. So when I flip it, it becomes 3, 6 times 7 over 11. When I multiply fractions, do my bottom numbers have to be the same? No, because you're just going to multiply them. So 3 times 7 is 21, and 6 times 11 is 66. Is it going to be positive or negative? I had a positive number divided by a negative number. It's going to be negative because there are different signs. Multiplying fractions, you do the exact same thing. You don't have to do keep, switch, flip though, because it's already there. You'll need to do the C method for each and then just go straight across. That's why I did dividing, because you have that extra step of keep, switch, flip. Now, multiplying decimals, this I will do both of, because multiplying and dividing decimals are two different things. So when you multiply decimals, you don't have to line them up. That's in addition. You just stack them up. I like to put the bigger one on top, or the one with more numbers, and then 4.7 on the bottom. What do I start by multiplying? What do I multiply here? Do what? 6 times what?
0.
No, not 0. What's my first number? 7. You don't add any zeros here. So you do 7 times 6, which is 42. Just like when you're adding, the number goes on top. 7 times 2 is 14. 15, 16, 17, 18. 35 plus 1 is 36. Now I'm done multiplying with my 7. What do I need to do? Easton? Not yet. There's one more thing you got to do. Landon? You have to add a what? I got to add a 0. And then I multiply with the 4. 4 times 6 is 24. 4 times 2 is 8. And 4 times 5 is 20. So I'm all done multiplying. Now what do I do? If I have my 2 rows down here, what do I do to my 2 rows, Esmeralda? I got to add them up. 2 plus 0 is 2. 8 plus 4 is 12. 8, 9, 10, 11, 12, 13, 14, 15. 4 and 2. Where would my decimal go? Shelby?
Miss Bealey.
Yes, ma'am.
We have Travis Roby.
Yes,
We
ma'am.
need him up front, please.
Okay.
Thank you.
So it goes right behind the 4 because you have 3 decimal places. So it's going to go 3 places over. So 24.522. Is it going to be positive or negative? I had a negative times a positive. Selena? It's going to be negative because the signs are different. Remember, multiplying and dividing, if they're different, it's going to be negative. Adding and subtracting, you take the bigger number. Okay, division. I'll set this one up, but we'll solve it in just a minute. So when I divide, I do long division over here. Am I going to, what number goes inside? The 3.6 or the 2.5? What? Your first number. Just like on the top, your top number or your first number went inside. Same thing. Your first number is going to go on the inside. So 3.6 goes inside. 2.5 goes outside. How do I make 2.5 into a whole number? Easton? Move the decimal over. And if I do it to the outside, I have to do it to the inside. So does 25 go into 36? Yeah. Goes in there one time. 25 times 1. And then, let's see, 6 minus 5 is 1. 3 minus 2 is 1. What can I do next? I can add a 0. 25 goes into 110 4 times. When you subtract, you have 10 left over. I'm going to add another 0, and 25 goes into 100 4 times again. Finally, I have 0 left over. Where does my decimal go up here? It's going to go straight up from where I moved it. It's going to go in between the 1 and the 4. Is it going to be positive or negative? I had a negative 3.6 and a positive 2.5. It's going to be negative because they're different. Okay. How do we feel about multiplying and dividing fractions and decimals? Yeah, I'm kind of there too, honestly. No one likes multiplying and dividing. Luckily, several of you have a calculator, so I would just use a calculator. Now, these two I wanted to go over. That's why I was kind of rushing, because I wanted to make sure that we had time to look at the word problems. We haven't done a lot of word problems in class, but you will have a couple on your test. So number 1, it says I can solve word problems using integers and rational numbers. So Whitney rolls a ball down a ramp that is 18 foot long. So you have a big ramp that's 18 foot long. If the ball rolls down 2 feet each second, which integer represents the amount of time that it takes to get the end? So it goes 2 feet, 2 feet, 2 feet, and so on. So every second it's going down 2 feet. So to solve this, you're either going to add, subtract, multiply, or divide 18 and 2. What would you do if the ball's rolling down the ramp and every 2 seconds, or every second it goes 2 feet? What would you do, Keelan? You're going to divide. So 18 divided by 2, we know is 9. So it would take 9 seconds to get to the bottom. This next one, Jason, this one's a little bit more tricky. So Jason spends $2.35 to buy lunch at school. He buys lunch for 9 days. What number represents the total change in the amount of money he has? So if lunch is $2 every day and I buy it for 9 days, am I going to add, subtract, multiply, or divide? Madison? I'm going to multiply. So 2.35 times 9. 9 times 5 is 45. 9 times 3 is 27, 28, 29, 30, 31. And then 18, 19, 20, 21. Where does my decimal go? Kimberly, where would my decimal go if I multiplied 2.35 times 9? It would go between the ones because you have 2 numbers. Now, the question said, what is the change in the amount that Jason has? So if Jason pays $29 or $21, is that going to be positive or negative for the money that he has? It's going to be negative. So my answer is actually going to be negative. Because it's not asking how much money he spent. It's asking what happens to his bank account. And his bank account goes down, so it's negative. We made it. So how do you all feel about this? So, I know, no one likes fractions. So the word problems are a little bit easier.